This video introduces the Xarkin Motion Module. These first scenes show full physical simulations of articulated assemblies responding to simple actuations. In all cases, the actuations are torques applied at joints. No external forces aside from gravity and surface contact are being applied. There are no magic hands moving these characters. They're responding as real self-contained physical systems would respond. The output of the simulations include full accounts of forces and torques experienced by each element, linear and angular velocities over time, and of course the positional information used to generate these scenes. The motion module is an embeddable component for generating complex character motions in real-time and non-real-time game and animation environments. As input, we start with one or more samples of motion, whether motion captured or manually created, and generate a motion module which extrapolates the samples in a physically responsible way over specified ranges of speed, turning radius, and slope for a given character. Transitions between gates and to and from a rest pose can also be integrated into the module. Once initialized, the motion module is sequentially queried for character locations and poses as the character moves across a landscape. In the current implementation, input to the module is the time-varying position of a target that the character will follow. In this demonstration, the target is a point that can be dragged around using the mouse. The character turns to follow the target, changes direction as it walks, and will adjust its speed depending on how far the target gets ahead of it. When it catches up to the target, it will transition back to the rest pose until the target is moved again. In this particular environment, the target path can be captured and replayed. To be clear, the path being drawn is not the path the character will follow, it's a time-based path that the target follows, whether it's moved manually, as in this demo, or by an AI. The motion of the character is always dynamically generated as it attempts to catch the target, and would be different for different characters or across different landscapes. As shown in earlier videos, the motion cycle for a character can be modified to project the desired emotional state or intention of the character. It can then be used as the basis for a motion module for that character. For this demonstration, the motion module is not directly tied to a rendering environment. A record of the character poses generated has been captured from the real-time module output and used to generate this clip rendered in Blender. It shows what a live character would look like as driven by the motion module. In terms of computational load, this instance of the motion module is not using a GPU and consumes something less than one CPU core to produce real-time output. Ongoing work with standard simulators and simulation techniques will continue to improve the quality of the output and extend its ranges. The goal is a system which will allow for design time and real-time choices along a spectrum of performance and flexibility versus CPU and GPU computational loads.